In this video, we will answer questions such as what is torque and horsepower, and what is the difference between them? What does it mean to have high torque? Is torque or horsepower more important? If you watch the video until the end, you will understand the concepts of torque and horsepower very well. Automobile enthusiasts talk a lot about the concepts of torque and horsepower. These concepts can gain importance not only for automobile enthusiasts, but also for those who want to buy an automobile. To understand these concepts, we need to make some definitions. First, let's define the concepts of work, power, and energy. Work, by definition, is the energy transferred when an object is moved a certain distance by an external force. If we formulate this, work equals force multiplied by distance. Let's give an example to understand this statement. Imagine a person who can carry 20 books, 10 meters. The person who carried these books on 6 trips covered a total of 60 meters by carrying 120 books. So how many times can a person who can carry 40 books, the same distance, perform the same task? The number of trips will be 3, and the work will be the same since 120 books will be carried. That is, if the person who can carry more books moves with a speed of 1 unit, the person who can carry fewer books will move with a speed of 2 units. This will be better understood when we give an example about the automobile. Now let's define the concept of power. Power refers to how long it takes to complete a task. In other words, doing the same work in a shorter time means having more power. If we formulate the concept of power, power equals work divided by time. In other words, power equals force multiplied by distance and divided by time. Speed equals distance divided by time, so power equals force multiplied by velocity. If we go back to the example of people carrying books, we can deduce from the formula that they both have the same power, since the total time they spent, the total number of books carried, and the work done are the same. But what is different in this example is the way the work is done. The person who can carry fewer books does the work faster and with less force, while the other person does the work slower with more force. In order to associate these concepts with automobiles, we need to make some definitions in the systems that perform rotational movements. By multiplying the force by the perpendicular distance to the center, we can find the rotational effect of the force, that is, the moment. Let's examine the equation of moment equals force multiplied distance. For example, if you turn the handle to open a door or turn the bolt wrench to tighten a bolt from a greater distance, it will be possible to create a greater turning effect or moment with the same force as the distance increases. Now let's come to the concept of torque. Torque, as in the definition of moment, refers to the rotational effect of the force. However, the concept of torque is used in rotating systems and parts such as wheels. If we exemplify this with a wheel, the value obtained by multiplying the radius by the tangential force applied from outside the wheel is called torque. So how is the concept of power expressed in rotary systems? If we adapt to the formulas we expressed before, we can express the concept of power by using the expression torque instead of force. So power is equal to torque multiplied by angular velocity. The concept we are talking about here is that if there is a rotating system and a part such as a wheel or axle is used, the resulting speed is the angular velocity. We express the unit of this speed as RPM. Angular velocity refers to the engine RPM in an automobile. Now, after explaining all these concepts, let's start explaining the meanings of torque and horsepower expressions in automobiles. The element that moves the automobile is the force transferred from the wheel to the ground. Let's explain what we said with a formula. Force equals mass multiplied acceleration. As the force you transfer from the wheel to the ground increases, the acceleration will also increase. If we formulate the torque of the wheel, we get torque equals mass multiplied acceleration multiplied wheel radius. If we examine the equation, more torque means higher acceleration since the mass and wheel radius will not change. Now let's define the concept of horsepower. To formulate the horsepower calculation, horsepower is equal to torque multiplied angular velocity divided by the number 5,252. However, there is something to consider when calculating according to this equation. When multiplied by the RPM given for each torque, the horsepower at that RPM is obtained. So each torque value corresponds to a different RPM. According to the equation, since the torque value is multiplied by RPM, as the RPM increases, horsepower will increase whether the torque is constant or not. It is also possible to say that horsepower refers to how fast it can accelerate with the applied force. Considering values such as the friction force due to the ground and the friction force due to the wind, the speed at which the automobile can accelerate represents horsepower. Torque is a value that expresses acceleration in an automobile. In torque value, concepts related to gears such as transmission and gear ratios need to be evaluated. We said that power is equal to torque multiplied RPM. In order to go at the same speed, it is possible to obtain the desired horsepower at low RPM in high gear as well as at high RPM in low gear. In other words, it is possible to achieve this by changing the angular velocity, or in other words, by changing the torque value. We mentioned the importance of the torque value transferred from the engine to the wheel. Since torque is increased by changing gear ratios, what is important is how the torque produced in the engine is transferred to the ground. Thus, the acceleration value increases. To reach higher speed, a higher gear must be used. In order to say that an automobile with a higher torque value accelerates better, the torque value transferred to the ground must be taken into account by looking at the gear ratios. Considering that the gear ratio and torque values according to the gear of two identical automobiles are the same, let us express the conclusions we will draw, and thus the subject can be summarized in general terms. The automobile with higher torque will accelerate better. We can say that this automobile will have better acceleration and traction on ramps. We can say that the automobile with higher horsepower can reach higher speeds with the effect of the speed concept in the formulas we mentioned. In other words, the maximum speed of the automobile with higher horsepower will be higher. Let's say you have two automobiles. Let one be an automobile with a gasoline engine and the other an automobile with a diesel engine. Gasoline-powered engines produce higher speeds but less torque than diesel-powered engines. Diesel engines reach higher torque values at lower RPMs. If your two automobiles have the same horsepower, they will reach the same maximum speed. However, the way they reach maximum speed will vary depending on torque and RPM. Other variables must also be taken into consideration when determining some values. It is important to understand the concepts and know what they mean, rather than questions such as whether torque is more important or horsepower more important. When making all evaluations, we cannot say that this value is more important and the other value is unimportant. These values will make sense depending on what you expect from the automobile.